All right. Hi, everyone. Thank you for joining us today for our Master Transfer Switch Equipment Basics and UL Standards webinar. Our speaker today, Lillian Raymond, is Socomec's Product Marketing Specialist, specializing in transfer switches. We appreciate your time, and we hope you leave this session with more knowledge and confidence about transfer switch equipment and compliance. There will be time for questions at the end of the session. Please use the Q&A option when submitting your question. And now, please welcome our speaker, Lillian.
Hello everyone, this is Liam from Socomec. Today we will go through the webinar series. Today I will take care of the transfer switch basics. Our first topic will be the transfer switch basics. We will go through the operation modes, the transition modes, and then we will see the downtime costs with the power unavailability, depending on different average businesses, different sizes. On the third part, we will go through the UL standards, UL 98, UL 1008, and different articles in the NEC, National Electrical Code. And as a fourth and last part, we will see how to choose and how to select the right transfer switch equipments. Firstly, why do you need some transfer switches in your electrical architectures? The main part of it is that every infrastructure may occur power outages during a year or during a lifetime. And for the past 20 years in the United States, 80% of the power outages has been caused by natural disasters such as snowstorms, hurricanes, high winds, and tree falls, and some more. But what it costs, it generates extra costs, direct and indirect, and it can come to thousands to $1 million. Such as penalties, production or data loss in case of data centers of large factories, some customer insatisfaction, extended lead time in some cases. But the most important thing about it, it can endanger people's safety. Some installation requires some emergency systems, and it can be a problem if the life safety equipment, the emergency lighting, and the fire alarms are not supplied, so it can cause very dangerous events about people's safety. So for that, we have transfer switches. It meant to ensure power availability, safety, and reliability for critical applications. So what a transfer switch is, it's meant to transfer to an alternate source when the main source is lost. The primary source could be the grid, as also called as a main, to an alternate source. The secondary source could be a generator, and there is different configuration about that. We will see that later. You can see in the middle, there's the device, the transfer switch that connects directly to the loads. A transfer switch is made to ensure a good power quality for the load, setting availability conditions that you can set up in some configurations, and it also permits safe operation for the maintenance team. So as the first part after the introduction, we will go through the transfer switches basics. First, the operation modes. There is 3 operation modes that you can see in the standards. The first one is the manual one. It operates between the primary source and the secondary source, could be main, so the grid and the grid. The main onto the generator and generator to another generator. It operates with a safe and easy, it operates with handles to have a safe and easy operations. It's cost effective by its design because it's simple. It has usually have a small footprint depending on the amp size. But the disadvantages of it is that it requires user presence to operate the handles and does have a slower restoration because it is not automatic at all. Second operation mode is the non-automatic one, which is also called remotely operated, because it can be operated in the remote with some push buttons, with some other external devices. So it has usually a compact design, a little bit less compact than manual one, because there is external device that has like a motor to operate it, and it does have longer time blackouts than automatic transfer switches, but less than manual transfer switches. And the third one, the The one that we are seeing the most in the United States are the automatic transfer switches. They are fast. They have a fast transfer time, and they are self-acting because they are operated by a controller. It senses the different data onto the sources, and allows the switch to self-act depending on the configuration that you set up. As it is more complex and self-acting, and there is a lot of electronics on it, it is obviously higher cost, which cannot maybe fit for every applications, but is the most advanced transfer switch that you can have on the market. Then on the transition mode, there is two. The first is the open, the second is closed. Firstly, we will go through the open. And in the open transition, there is two subdivision. The first one is the delayed transfer. So it does have a center of position. The time transfer is usually above 50 milliseconds. The sequence is, firstly, the first source will disconnect. We will wait for a preset delay. You can set it up in the controller if it's an automatic switch. Otherwise, you can wait manually if it's a manual transfer switch. And third part of the sequence, you will connect the source 2 when the source 2 will be available to connect. So the good point with it is that it prevents and reduces high inrush currents. It protects equipment from damage due to the residual energy because it has the time to dissipate in the center of position. And the disadvantages of it is that there is a longer outage. It cannot be it can be unacceptable for some loads if it's in like IT, if it's critical loads, like in data centers, in hospital, it does not fit sometimes. And it requires more configuration of delays and timers, so it can be a bit more complex to configure. And it is usually it usually applies to inductive loads such as motors, compressors, HVAC, etc. And the second one, which is also a break before make sequence, this is the in-phase transfer, so there is no off position right there, as it is at the delay transfer. So the sequence is, firstly, we disconnect the source 1, and when the second source, the secondary source is available, it will connect to the source 2. So the transfer is faster, the design is simpler, the costs are lower, because the design is simpler. But what we need, and what could be a risk about it, it's if the inductive loads, residual energy can cause spikes if the synchronization between the two sources are not made perfectly, which can cause many damage on the equipment on the loads. It applies to many applications and many segments. It can be to the telecoms, to small motors, so to IT infrastructures, to HVAC, to lighting. There is many applications. This is the most common technology here in the US. The second transition mode is the closed one. Before it was a break before make sequence. The closed transition is a make before break sequence. And the sequence would be first, the device will verify the synchronization between the source 1 and the source 2, or if it's a manual transition, a manual operation, the operator needs to verify the synchronization between the two sources. As a second step, the source 2 contact will close, so there is a bit of a paralleling between the two sources. And as a first step, the source 1 contacts open, so the source 2 is the only source powered to power the loads. This is good because there is no power interruption, so it's very it can be very relevant to add close transition transfer switches in some application, like IT infrastructures, when there is a need for no blackouts, and there is a need for life safety systems for medical imaging and telecoms. But as it's a bit complex, there is of course higher costs. And what I think is also very important is that the paralleling may cause dangerous currents if synchronization fails. So it needs to be synchronized in voltage, frequency, and phase. Second part, the downtime costs. We will see the power availability. So power availability is the proportion of time which an electrical installation is operational and able to supply good quality power. You will see on these diagrams represent availability of every circuits and apparels depending on the transfer switches equipment technology. If we calculate the total of availability of each devices on this design, it gives us the times when the loads are not supplied every year. So what you can see on the transfer switch equipment circuit breakers, CB means circuit breaker, and the transfer switch equipment PC, power contactor, is that the unavailability of circuit breakers design is almost at 4 hours a year. And for power contactor is almost at 1.2 hours per year, which is about 17 times less downtimes with power contactor technology. What is important to say here is that, only by choosing a switch technology, you will have more or less downtimes, which also results by a loss of profit at the end. So the 17 times yearly unavailability is even more real when we look at the total cost for an average business. So the table that you have here on the screen is a basic comparison of the average cost based on your business size and your chosen switch technology. If we have a look at the large size business, for example, which could be like an airport, a small data center, large industry, whatever, and based on different studies and documents, we estimated that an hourly cost of power unavailability will be between $500K and $1 million, which results as approximately $2 to $4 million loss a year for circuit breaker technology, and around $100 to $200K for power contactor switch. But this is an average. But if you look at bigger business size, such as big data center or large financial companies, it could be like financial loss such as $5 to $10 million per hour, which is a big loss for these such infrastructures. Now we'll go through the standard differentiation. We have the UL 1008, which apply for transfer switches that are designed for critical power application with higher endurance and overload capability. And we also have the UL 98 that are made for disconnect switches. They are made for standard branch circuits with less demanding requirements. So as there is less requirements, of course, for UL 98, they are also cost effective than UL 1008 products. And if you look at the UL 1008, there is two columns. One is for the resistive loads. The tests are less restrictive than total system because they are easier to switch. The products are easier to switch, or there is no large inrush current or stored energy in the devices into the loads. And in the total system, it represents a mix of load. It can include resistive, capacitive, or inductive loads as well. And it requires more robust tests to ensure power availability under more severe environments. So what we can see, it's in yellow on the table, is that for the resistive loads, transfer switches are tested 50 times with 1 times the operational current with a 0.75 power factor. And for the total system, it also required to test switches 50 times, but with a 0.4 power factor at 6 times is operational current, which means if you select like let's say a 400 switch, it will be tested at 2400 switch, at 2400 amp, sorry. So those tests simulates several conditions that can occur with highly inductive loads, like large motors, and it answers the switch that can withstand such stress. I have a quick look on the UL 1008 specific part is the withstand and closing current ratings. So first, the withstand current rating is the maximum short circuit current that the transfer switch can endure without damage for a specific duration. And the closing current rating, this is the maximum short circuit current that the transfer switch can close into without damage. After that, you can choose between fuses. It's usually any fuse ratings. So it will mention the type of fuse that you can select with the right short circuit rating, depending on the voltage rating, and it will give you all the advice to choose the right one. Or either, if you don't want to choose fuses, you can use circuit breakers as an over circuit protection devices. And there is two different type of ratings that you can see. The first one is specific breakers. So specific breakers rating, this is the use. You can use the transfer switch only with the specified breakers and comply with the short circuit conditions. So here is an example of Siemens, Eaton, Squarey, and Schneider Electric circuit breakers, and we will have different ratings depending on the different brand, on the different circuit breakers. And the other one is the any breaker. It is for use when the transfer switch with any circuit breaker on the market, but usually as it is for any breaker, the SCCR, the short circuit current rating are often lower than with specific breakers. Then we have some standards that are mentioned in the NEC, the National Electric Code. We have the Article 700, which is meant for emergency systems. What an emergency system is, this is very easy. This is the most strict one. It says that the transfer switch must be automatic. It must restore power within 10 seconds of outage. And there is some requirements about the system, about the test upon the installation, and some written record that we must keep when it's installed. And there is also some inspection every year. When and where does it applies? This is where life safety does matter, which can be in hospital, in large C&I building with a large amount of people, like stadium or whatever. And for critical loads, also in data center, because the data loss will cost a lot to those infrastructures. If we look at the C&I building, where can we find those life safety emergency system rating? Is that for emergency lighting, for fire alarms, for evacuation? We need to have the elevators operating, so we need to have a power supply. Second article is the Article 701, which means for the legally required standby systems. So this is made to support emergency responders and health hazard control. It must restore power within 60 seconds. The application are less than an emergency. They are more common. This is mainly for smoke control systems, for HVAC, for some communication systems, and we can find that in the typical infrastructures as C&I building, some hospitals and data centers, but this time it will be the non-critical loads. The emergency system was for the critical loads, and we can also find it in some telecom architectures. And the last one is the Article 702. This is the optional standby system. This is the part of the standard where there is no life safety requirements. This is more to prevent financial loss in case of power outages, or just install for convenience if there is a need for maintenance or something like that. It's easy, but there's no life safety behind that, and there is no mandated restoration time. Sorry, as it's not an emergency, and this is not critical loads. So we usually find that for backup generators, for internal processes in large industries, into HVAC systems, and the different infrastructures that we see is C&I building, non-critical loads in data centers and hospitals, or either in residential infrastructures. Right now, we'll see how to choose the right transfer switch equipment. First, you need to define what would be the configuration, if it will be utility genset, utility, or genset. Before choosing a transfer switch, it is preferable to see with the manufacturer if the switch can operate in both three application. Some does not meet the requirement to be genset or utility. Some are only utility gensets. So you need to check that on the manufacturer's data, sorry. Secondly, you need to see what are your requirements in terms of standards. If you need to meet emergency systems requirements, you will need to have an automatic switch. So you will choose the automatic switch type. Then you need to choose the switch position, the number of switch position, if there is 2 position or if there is 3 position. 3 position means there will be a center of position to do some delay transfer or just to have a preset delay. Transition type, if it's open, so you can do in-phase transfer, in-phase transfer or delay transfer, as we see earlier, or closed transition for more like non-blackout, to have no blackout for the loads. You can choose the voltage depending on the configuration, depending if it's for generators, you can choose if it's Y, if it's delta. You will have more, you have many configuration available for many projects on the market. And then you will choose the current rating. 2 things about the current rating, you have the operational current and the short circuit current rating that you need to choose with the right breaker or the right fuses to combine it and make your installation safe. We also make for you a more visual decision tree. So this is more about the Socomec products. I don't know, for example, if I want to have a UL1008 switch with an optional standby system requirement, I don't need the emergency systems. I want a remote operation. Do I need a delay transition? No. Okay, I will choose the 80 UL. Do I need the remote operation? No, I will need the manual operation. Okay, I will have the Circover UL rated as UL 1008. If I need an emergency systems, yes. I need a delayed transition. Yes, I will go through the 80s DT with its delayed transfer, automatic transfer switch, and it will apply for fire pumps, fire alarms, emergency lighting, elevators, something like that. So you will have that on the presentation later. So it will be more easier for you to choose the right transfer switch for your different application. And last thing will be about the Socomec North America transfer switch offer. Very quickly, very basic. We cover the 3 operation modes, which means manual, non-automatic, and automatic. The current rating, I won't go through it. It's easy to understand. Different voltage configuration. What we need to know is about the standards. All of our products are rated as UL 1008, and the Circover UL also meets UL 98 as a changeover switch only for 600 to 1200 amps. If you would need emergency systems rated products or legally required system, you will need to have an 80s FT, which transfer from a source 1 to source 2 in less than a second. And if you will need optional standby system, we will have the Circover UL as manual transfer switch and the 80s UL for non-automatic or remotely operated transfer switch, which occurs in 1.3 to 3.2 seconds. And if you need more information on the Socomec transfer switch range, you can reach out to me later by email after this webinar or to your area sales manager. And we will have another webinar on January 29th at 2 p.m. same hour If you want to learn more about the ATS controller and power monitoring, or to do some load shedding, or to add some IO modules to your installation, to your controller, to do more advanced functions, we will have a webinar about it with one of my colleagues. You can register by this QR code. And yep, this is the end of my presentation. I will see in the Q&A section if there is some question in the chat or in the Q&A. You can ask it in the chat, and I will try to answer it and do my best for you. I don't see anything right now. I don't know if it's just on my, or if there's no question. Okay, question of Mark. You have a published list of WCR ratings for the circular switches. Yes, we do have it on our catalog. I don't have all of the ratings in my mind, because it depends on the switch size and everything. But we will reach out to you and send you the catalog and all the information about the circular switches if you want to learn more about it. This is not a problem. Does Socomec provide enclosures? No, we don't right now. We do have some partner that enclose our products, but right now we don't provide enclosures. But in our documentation, in our data, in our instruction sheets, we do say all of the frame size of a switch, and we recommend some enclosure size as well. So if you want to buy the switch standalone and enclose it, or have a partnership with, I don't know, with a panel shop or something, it's a possibility. Robert Simon, how do ball switch Geneva switch fit the offering? You're right. I didn't spoke about ball switch. Socomec acquired ball switch many years ago, and it's part of Socomec's products on its own. It's not a different brand at all right now. It's Socomec. But it fit this offering. They are mainly UL 98 and UL 977 products, and goes up to 4,000 amp as UL 98, and can goes up to 6,000 as non-UL. But if you want more data about it, Robert, I will send you all the information about ball switch. Is there any question? Okay. Is the ATS-DT available? I know there had been some function issues hindering production. This is a good question. Right now, the ATS-DT is not available, but it will come soon on the market again. I can't provide you when we have an estimation about it, but we won't tell you. But it would be this year for sure. Paul Skinner, thank you for your questions. When we will have FT-DT switches rated more than 400 amp, we are working on it right now, and we do have ISC products that are more than 400 amp. They are not UL rated right now, but yeah, this is on our roadmap, and we are working on it to have more than to have automatic switches more than 400 amps. Do I have more questions? New posts? If high SCCR is required fused, should we install upstream or downstream ADS? I'm not sure to understand the question. I will check about it and come back to you, Faris. Yeah, I think we are done with the Q&A section. If you have any more question after this webinar, you can still ask it on the chat, and I will answer it. I will answer it later. Thank you everyone for joining this webinar. I hope to see you again on the 29th of January webinar for the ATS controller and monitoring. And it was a pleasure to host this event. Yeah, my pleasure to have you on this call, and see you.